Okay, I am going to explain to you the workings of a three-way and four-way switch. It is one of the most common questions I get from people. Hey Jeff, I just don't get these three-way switches. How do you do it again? And I have the same people asking over and over, and many times I just end up doing it for them because they just don't get it. So let's take a look at what goes on here. Okay, so first off, here is a just a standard switch. Okay, let me position that. All right. So here is a standard on-off switch. And you turn it on, the light goes on. You turn it off, the light goes off. And see here, there is the off. You flip it up and it says on, and it is on. Okay, so the single pole switch is just a break in the line. It's just like a straight piece of wire going up to the light, except for you can break the line. So you attach it or you break it. Alright, so a three-way switch is doing the same thing. You have your light is on. We're just going to ignore this now. That's a straight piece of wire. There's no switch there. We're just dealing with the three-way switches, okay? So, three-way switches, when you have them wired properly, when they're both up, the circuit's on. When you have one of them up or down, the circuit's off. When you have them both down, the circuit comes on again. So what's happening inside of there? Well, you have, when you have them both up, you've got your wires are going like that. So you've got your okay, we'll hold them in here like this. You've got your black wire and your red wire. Okay, so now let's switch it. Okay, well now you have crossed over your wires, right? So now what you have to do is cross over the other switch to make the light work again. So now you have both wires, travelers, are oriented the same way. So when you have them both up, they work. If one is down, they don't work because you've crossed the wire. And you cross the wire again, and then you uncross. And you uncross, and the light goes on. So that is what's happening inside a three-way switch. And what are you doing when you connect these three-way switches? All right, well, here is the common, and there is the first switch in the circuit, and there is the second or last switch in the circuit. Three-way switches only come in pairs, and the first one, whenever you have the first switch is the one with the power, and you connect the power to the common screw before anything else, and then the red wire will connect up on this terminal, and the other black wire will connect up on the other terminal. They're both brass screws, and the common is a black screw. And you've got your red wire here, and you bring it over to the same side on the second switch. Just like the black wire goes to the same position on the second switch there too. And then you have your common wire on the second switch, and that is the wire that goes to the load or your light. So in this case, that common wire is going across over here to the light, and that is basically, we're going to call that the ceiling light. Okay, so what do we got going behind us here? We have Incidentally, these are called Wago connectors, and I like them. They work really well. You can connect. They have them with like 3, 4, 5 different connection points in them, and 2 just to splice. But they have a quick release on them. So here's what they look like here, and they have this little spring tab on them. See if I can do this one-handed. Everything is harder one-handed. Okay, so there you see down inside of the connector, you can see that one side you can see is 2 of them are closed and 1 is open. So let me just close that, and there, now you see they're all 3 closed. And so it snaps down nice and hard on the wires, holds things in position. Alright, so Wago connectors. They come in a box like that. And this box, I think this box of, what was it? What was in there? 50 of them, I think. That was $27. So they are expensive, but they do a good job, and they connect really well with stranded wire or with solid wire. All right, so let's get back to our topic at hand here. We were talking about, okay, so we're just ignoring the first switch in here. We're just calling that a straight piece of wire. So here is the black power wire that comes over to the common wire. And then you have your red and black travelers. So you have your red is on that side, and it goes over here to, okay, that's the, we're not talking about that one yet. And it goes over to there on the second switch. And then you have your black wire on the first switch, and it comes over to the same position on the second switch. Okay, and then the white wire of the 12-3 is going to come off of the common. And this wire here, it is still a hot wire because it has not gone through the load yet. The white wire will not become a neutral wire until after the load. So before the load, it's hot. After the load, it's neutral. Okay? And it's the return path to the neutral, and completes the circuit. So anyway, we have the white wire is coming across, and it's just being connected across the circuit here back to where the source wire is, the power wire. So you've got the black power wire is coming in and connecting up to the common, and the white wire is connecting to the wire that goes up to the light in the ceiling. And then so technically now what I should have done here was put black tape on this wire. Well, actually I did do that, didn't I? Okay, so yeah, and that's right. This wire here, this is the wire that's coming from the common over here on the second switch, and it is still hot, so it is the wire that connects to the black wire going up to the light fixture. And then after the light, now the white is neutral. You don't need the black wire anymore because it is after the load. And so it just comes back down from the ceiling here and back to the power wire and returns to the electrical panel over there. Okay? And nobody saw that. Don't do that. That's not the way you're supposed to do it. I do it because I know what I'm doing. Okay. So now we're going to put a four-way switch into our circuit. So let me just peel this off And yeah, let me just make sure that I did the explanation here with when you switch one wire, it crosses the wires, all right? And then when you switch the other one, the light comes back on and the wires are realigned. Okay? So maybe that's a better way to think about it. Instead of thinking of them as being crossed over, think of them as aligned and not aligned. Aligned, not aligned. Okay? So anyway, when you have with just two three-way switches, when they are both up or both down, the circuit is on. And if they're both up, the circuit is on again. And if they are not the same, one's up, one's down, then they are not aligned, and the wires are effectively crossed over and switched. So the circuit won't work until you switch the other switch back to match the wires up in alignment. All right, now let's throw a four-way switch in here and see what happens. And there you go, by the magic of electrical tape and paper, we have a four-way switch. Now, one thing I'm going to show you here real quick is the difference between, here is a four-way switch. Okay, now let me flip this over. And if you look there, you can see that the four-way switch is labeled, there's input. Okay, you see that? Let me move the wire out of the way. There's input. And down here, you have output. Okay? And what you are doing is, from the first switch, these two are your input wires, and your output wires are going to the second or the last three-way switch. And if you have multiple four-way switches, and you can have many of them, then you'll have just remember, outputs go to inputs, and inputs lead to the output on the switch, and those outputs go to the inputs. And if this was another four-way switch, it would be the outputs go to the inputs. Okay, so an output goes to an input. And, of course, the first thing you have to have is the input, which would be your power. And that is what is happening here, is you've got your first switch here with the common, and that is your power up here. And then these two here, both of these are going to be carrying power. Only one of them at a time is carrying power. And it depends on if you have it switched up or switched down. One is up is going to be one of the two, and down is the other of the two. So the wires will just kind of go from input, output, input, output, input, output, and on until you get to the end of the run, where the output on the common of the second is always the last three-way switch. The common wire goes back, and it's in this case it's still a hot wire, and so it gets here, it connects up to the black going up to the light, and then the white wire of the light comes back down, connects to the white wire that goes back to the power source, breaker panel. Okay? And so that's one of the things that gets confusing to people, is that you end up with two white wires, and people think, oh, gee, I can't cross two white wires together. Well, you got to remember that this white wire here, that is the output. It's the end of the run for all the switching. So you have to, think of it like you've got your power comes in, and then all of this wiring and switching here is basically just an on or an off switch. And where am I here? Okay, so let me switch this here. Yeah. There. Okay, so it is either on or off. And all of these wires here, all of these three switches or more here, they're either an on-off switch. It's just that you have a whole mess of wire doing the job, and you just have to remember that basically all that's happening is it's just aligning these wires either straight through to complete a connection or flipping them over to break a connection. All right? So, now there's also several different ways that this can be connected, and in this case here, you see we've got our power wire comes in, feeds the three-way, goes through the four-way, goes to the second three-way, and then it works its way back over here to the load, the light switch. So in this case here, the first switch has the power and the load coming into it. And so you have to get this load wire back over to that switch, okay, the first switch. Now what can also happen is you just kind of have to imagine here that this load wire, you can connect this at this point, at that point, or just right here. If you have a wire going up to the light here and coming back down, then you would connect your black wire from the going up to the ceiling. You would connect your black wire to the common on the second switch, and that would go up to the light and then come back on the white wire. And then because it's coming from the load, now it's a neutral wire, so you wouldn't need to wrap tape on it because it is a neutral wire. It's not the hot wire anymore because it's already gone through the load. All right. So we could we can see how this works if people like this video or not. It's kind of a confusing thing to explain it, because you're explaining a lot of stuff and you're trying to keep it all in your little mind, what you've been talking about, and you're trying to make so many explanations and associations to explain it that you kind of lose where you're at. Okay, so now did I explain here, this looks like another four-way switch, but this is actually a double pole switch. And so if you remember here, the four-way switch has the input and the output, whereas the four-way switch has the line and the load. And so it's going to be, there's two ways to use that switch. One way is if you have a 240 volt circuit, you're going to have your black and red or black and white wire come in here, and they're going to go out through the load connection or terminals. And you could also, if you had, for instance, two counter outlets, 120 volt counter outlets in your shop, and when you leave your shop you like to turn both of those counter outlet circuits off, then you would use a double pole switch like this, and you would have one 120 volt circuit on this side and the other 120 volt circuit on that side. And this is a 30 amp switch, so it's a very well built heavy switch. Okay, so it's just one thing that you might want to make sure that you have the correct switch, because it would not be the first time that one of these switches has been swapped out in a box or grabbed by mistake because it looks similar. Okay. All right, well, I hope that this explanation does it for you. And just a quick recap here, you have your power comes in to the common. That's your input. And then your output are these two traveler wires. And with a four-way switch, they go to the input on the four-way switch and to the output. From the output on the four-way switch, they go to the input of the next four-way switch, or the second three-way switch. And remember, there are only two three-way switches in a three-way circuit, and any additional switches are four-way switches. Okay? So there's a couple of different types, different connections of three-way switching. So maybe I will redo this video to show a different connection on three-way switches, and maybe my explanation skills will have improved. But anyway, that is my explanation on three-way switching. You have got a three-way switch is basically, it's an on-off switch, except for you're doing it from multiple locations, and it takes three wires to be able to do it back and forth. And so in this here we've got 1, 2, 3, 4, 5, 6 different wires being connected, and it's not all that confusing. It's a lot of wires, but it makes sense once you do it. Okay, and so I've just kind of labeled things here to help explain. This is a single pole switch. All it does is on and off. It's just a break in the line. Okay, and that's what a three-way circuit is. It's a break in the line. And even with all of these here wires in here, it still comes down to it's breaking one connection in there to make the circuit either on or off. Okay, so it's either making or breaking a single connection, just like this. It's making or breaking, making a single connection. Okay, and so we have the power is your input, and the two traveler wires are your output going to the input of your four-way. And I guess the input is down here and your output is up there, and your input is down here. No, your output's up above. Okay, and there is your common down here, and your common is your output from the last switch, and that goes over to your light. And you can either have your light on this switch, that switch, or that switch. In this case, our light is on the same switch where the power comes in. And if you do take power from here, or from here, or from here, you can only take power from one light switch, because you send it up to that light, and then it goes through the load and comes back down, and then you cannot run it up through any of the other connections, because at that point it becomes a series circuit. And so you only want parallel wiring, and a single load is in series, but multiple loads connected in series becomes a voltage divider, and things start to not work. Okay, and it's not so much that wiring things in series is really dangerous. The more things you have in series, the greater the resistance, and so the less stuff the less current can go through the wire. But when you have things wired in parallel, then you get the full current through each individual device connected, and if you've got 3 10-amp devices connected in parallel on a 20-amp circuit, well, you've got a 10-amp device plus a 10-amp device plus another 10-amp device, and you have got 30 amps going out in one circuit. So if you had a 10 and a 10 and a 10 in series, then the first 10 would become a voltage divider, so then you would have a 5-amp circuit, and then the third one would drop it down again to, say, 3.5 amps, because your resistance isn't allowing more current to pass, it is restricting current from passing. Okay, so anyway, I'm probably confusing too many people at this point. All right, well, that's it. You can give me your comments here and tell me how much I confused you or how much I helped you, but hopefully it helped you. Okay. All right. I will redo this video here at some point and try to be a little more succinct on it. But I think we got the basic description, explanation across. Okay. And you can just kind of read the labeling on those switches. Alright, I will see you on the next video. Hope you enjoyed this one. Leave your comments, and please do subscribe. I could use all the subscribers I can get. Thanks for watching. Take care. Archie, am I really not paying you enough attention? Is there really not enough attention being paid to the cat? I'm trying to put together a video here, and you're really not helping. You're not helping. That's not a cat toy. Not a cat toy. Good boy. Attaboy. Attaboy. Don't do anything stupid, okay? Don't do anything stupid.